Welcome once again, students. Today we shall start the chemical reaction and we'll try to finish in one shot. So that first, what is chemical reaction? We will study that chemical reactions are the process. It is the process in which new substance with new property or properties will be formed. So a chemical reaction is the process in which the new substance will be formed with new property. Note, in chemical reactions, the atoms of one element, here is an element, here is substance. You will note down this thing. Elements I have told to you in that periodic table. So in chemical reactions, the atom of one element do not change. So you will note down it that atoms are not going to change. In 9th class, what are these atoms? You know that electron, proton, neutrons will be present inside the atom. So those atom is not going to change. Only the rearrangement of atoms takes place. Okay, so these things are there. We will note down that atoms are not going to change, only the rearrangement of those atoms will take place. Have this screenshot here. I think you may confuse between the things of that element, compound and mixture, all these things. So you should note down that what is element? Element are the substance that is made up of only one type of atom. Okay. So what is our element? That it is the substance made up of only one type of atom. And compound, if we are talking that substance that is made up of more than one type of atom. More than one type of atom, a substance with more than one type of atom will be called as compound, and substance made up of only one type of atom will be called as our element. Whereas if you are looking to the mixture, it is the combination of two or more elements or compounds. So the combination of two or more elements or compound will be called as our mixture. So what is atom? I think in your 9th class, miss, you may have studied these things. Still, miss, have the screenshot. I am rubbing here. Is that what is atom? You may get confused in that atom as well, I think. I am telling you in a short way that atom is the smallest part into which an element can be divided. So the smallest part of the element will be called as your atom, and you all know, suppose it is atom, there will be subatomic particle, and that is called as in atom you will find nucleus here. In nucleus there will be neutron and proton, and electron will be around to the nucleus. Here you will have the electrons here, and it is neutron and proton. It is called as our nucleus. So it is our atom, and in atom there will be also subatomic particles, electron, proton and neutron. And what is atom? Smallest part into which an element can be divided. And what are the different types of element? I have told you in the periodic table. Okay, first you will study periodic table, then only you can understand these chapters. Okay. So come to the chemical reaction. Suppose we have two substances A and B, and after chemical reaction, okay, after chemical reaction these substances will form new. It is the chemical reaction process in which new substances will be formed. So if we are considering two substances A and B, and after chemical reaction these form C and D. C and D. So how will you write this? Suppose we have the two substances A and B, and we are reacting that. And we are getting new substance with new property, and let us, that is C and D. Okay, C and D. So student, first the left side, this left side substance will be called as our reactant. It will be called as our reactant, whereas this right side substance will be called as our product. Okay. So suppose we are considering two substances A and B, and after the chemical reaction we are forming C and D. Then we can write that in this way, and the left side substance will be called as our reactant, and right side substance will be called as our product. Okay. Have this screenshot. Now what can be the examples of chemical reaction? So here will be that read out some example. That first example you can consider that burning of magnesium ribbon. Magnesium ribbon. Magnesium is your Mg. I have told to you that in periodic table. So burning of magnesium ribbon can be the example of chemical reaction. Some other examples are souring of milk in hot days. Souring of milk in summers, that milk get sour. That is also the example of chemical reaction. Some other example can be that digestion of food. Digestion of food in our stomach, that whatever digestion is taking place, that is also the example of the chemical reaction. Other example can be our respiration process. Respiration process you will study in that biology. Next example you can say that burning of fuel. Burning of fuels is your that coals, oil, petrol, diesel. Okay, so these can be the examples of that chemical reaction, and there can be other example as well. So write down up to here. Now student, come to an activity, and in this activity, that what will we do? We will burn the magnesium ribbon in air. for burning, that there will be requirement of air. So here you are looking, there is a magnesium ribbon, and that we are burning with the help of burner, and we have hold the magnesium ribbon with the help of tongue, and here is a watch glass, and we will do this activity. You will draw the figure, and please student, while are you drawing the figure, now you should name that figure, that you are drawing which figure. Okay, it's good for the board exam. So it is the figure of burning of magnesium ribbon, burning of magnesium ribbon in air, and the collection of magnesium oxide in watch glass. So we are burning the magnesium ribbon and collecting the magnesium oxide in watch glass. So you are looking that when will we burn the magnesium. So for burning there will be requirement of oxygen, and that we will have from the atmosphere, from the air. So when you will that burn magnesium in the presence of oxygen, you will get magnesium oxide. You will get magnesium oxide. So here Mg is there, magnesium plus oxygen. Oxygen, you guys know that oxygen, we will write 2 here. We will write O2, not O. Okay, it will be 2 atoms of the oxygen. So we will get here magnesium oxide only. So magnesium oxide is MgO. So here is 2 oxygen, here is only 1 oxygen. So I will tell you in the balancing of the chemical reactions. So here is 2 oxygen, so you will consider 2 Mg here, and it will become 2 MgO. This thing I will tell you after some seconds. So this will be the chemical reaction, and what will you look, that your observation will be that observation, whatever activity we will perform, that will have some observation, and that observation is that magnesium ribbon burns with a dazzling white flame. Dazzling white flame. It will have the white flame. It will burn with dazzling white flame and change into white powder. Change into white powder. Okay, you will look that when it will burn, we will get the white powder of magnesium oxide, MgO, magnesium oxide in the watch glass, and it is our observation. So what are you looking? That we have considered the reactant here. Here is what? Left side is reactant. Reactant is your magnesium and oxygen, and here we are getting the product magnesium oxide. It is our product. Okay, so it is a chemical reaction. And please note down that while you can note that while are you that burning the magnesium ribbon, you will with a sandpaper you will rub magnesium ribbon with sandpaper. So that in chemical laboratories, wherever will be the magnesium ribbon, that you will rub with sandpaper Why will you rub that? Because now that can form oxygen on it. The ribbon can have the protective layer of oxygen, so that oxygen you will rub, then after you will perform this activity. Okay. Once out, read it and write it and try to understand. It is the activity. We are burning the magnesium ribbon and getting magnesium, white powder of magnesium oxide here, and it is an example of chemical reaction. You will rub the magnesium ribbon with sandpaper before burning that. Now come to the one more activity, and it is the activity of formation of hydrogen gas. So we are forming the hydrogen gas by the action of dilute sulfuric acid. So you will have the conical flask. You will have the conical flask, and in that conical flask, in the zinc granules, these are the granules of zinc. In that, when are you adding the dilute sulfuric acid? Please try to that come through the things. Dilute sulfuric acid, when are you adding in the zinc granules, you will look that hydrogen gas will evolve from here. So we will get the hydrogen gas by the activity this. And in this activity, what do? We are considering the zinc granules, and on that we are adding the dilute sulfuric acid. Sulfuric acid will be written like it. Please try to that come across the things I am telling to you. Sulfuric acid, H2SO4, learn it. This is our dilute. Dilute means what, student? It is, you can say patla, okay? Patla hai, it is not concentrated, it is dilute. Dilute sulfuric acid, when you are that zinc, in zinc granules you are adding that dilute sulfuric acid, you will look, it will form ZnSO4, and here H2, hydrogen gas. So gas we will represent by an arrow upside. Okay, so I will tell you about this. So it will be this reaction will take place. It will be called as your zinc sulfate, and here you will get hydrogen gas. So it is the next activity. We are getting hydrogen gas by the action of dilute sulfuric acid on zinc granules. Here you can write that on zinc granules. Okay. So student, of course you will look, this side will be called as our what? Left side will be called as our reactant, and this side will be called as our product. You are choosing substances zinc and sulfuric acid here and getting new substance with new property, and that is zinc sulfate and hydrogen gas. So it will be a example of chemical reaction. So what are the characteristics of chemical reaction? That we will write here, that characteristics of chemical reactions. Okay, chemical reactions. So the characteristics we are getting by the activities can be that evolution of gas, evolution of gas. Other can be formation of precipitate. What is precipitation process? All these things where we are just going to reach up to here. For the time, write it. Precipitate. It is also abbreviated as PPT. That formation of precipitate, that there can be change in color. These things we are just going to discuss. For the time, write it. Change in color, change in temperature can also take place. Change in temperature. Okay, and there can be change in state as well. Change in state. You will look that here the zinc granules are there, solid state, and dilute sulfuric acid is your that liquid kind of the thing, and we are getting gas here in the product. Okay, so it is your solid, it is your that liquid, but here in the product we are getting gas, so there can be the change of state as well. So this will be your characteristics of chemical reactions. Write it, pause it, and have this screenshot. Now come to the one more important point to note. And that important point of note is your that balanced reaction. What? Balanced reaction and unbalanced reaction. So what is our balanced reaction? In balanced reaction, atoms on both sides are equal. So the number of atoms present on the left side will be the number of atoms present on the right side. If both the side atoms are equal, so that reaction will be called as our balanced reaction. Whereas in the case of unbalanced reaction, atoms on both sides will not be equal. And you will note down that an unbalanced reaction is called as skeleton reaction. So unbalanced will be called as our skeleton reaction. Suppose you guys will be aware about it that if we are taking hydrogen and oxygen, what will form? That our water will be formed, H2O. So whether is it balanced or unbalanced? Here 2 atoms of the hydrogen are here, 2 atoms of the oxygen are here, there is 4 atoms. But here 2 atoms of the hydrogen and 1 atom of the oxygen is present. So here left side is 4 atoms, here is 3 atoms. So it is not the balanced reaction. It will be the skeleton reaction, unbalanced reaction. So how do we balance that? Now we will try that. Here one thing you can do to make it balanced? H2O2. H2O2. But this will be wrong. This will be wrong because H2O2 is your hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide, and I am writing here hydrogen peroxide, and change molecular formula, and we cannot change molecular formula. That our molecular formula cannot be changed. If you are writing H2O2, it will be hydrogen peroxide, and the molecular formula will get changed. And you know that hydrogen and oxygen will give us water. It is not going to give you that hydrogen peroxide. So we cannot change the molecular formula. I am rubbing here. So that H2O2, H2 plus O2 if you are considering and getting water here, don't balance to make H2O2 because it will change molecular formula. So this thing you will keep in your mind that in this way we can't balance. So what is the other way of balancing it? So here you are looking, here is 2 hydrogen is balanced, O2 is there, here is O, here 2 oxygen is there, 2 atoms of the oxygen are on the left side, here is 1 atom of the oxygen. So what can you do? You can, I think, increase 2 here to make 2 atoms of the oxygen. So when you will increase 2 to make 2 atoms of the oxygen, that your hydrogen atom will become 4 on the left side. And you are looking there here on the right side that hydrogen atom will become 4. On the left side there will be here is only 2 atoms of the hydrogen. So can we think to make it 4? We can do like it. Of course, here you are looking now 4 atoms of the hydrogen on the left side, 4 atoms of the hydrogen on the right side, 2 atoms of the oxygen on the left side, 2 atoms of the oxygen on the right side. So the balanced reaction will be nothing but your 2H2 plus O2, and that will give you 2H2O. I think that what will we do in that balancing? We have discussed that in balancing we will balance the atom on the left side and the right side. If the atoms on the left side and the right side are not same, that will be the unbalanced reaction, and that will be called as our skeleton reaction. Of course, suppose you are considering S2 plus O2, and here you are getting SO3. So here is the 2 atoms of that sulfur is present. 2 atoms of the sulfur. Please read the periodic table, then only you can understand what is SO. The symbols I have told to you. So 2 atoms of the sulfur is present on the left hand side. So what can you do? You can increase 2 here. So when are you increasing 2 here? You are looking that oxygen atom will become 6 here. 3 to the 6. Here is 2 atoms of the oxygen is present. So what can you do? You will write here 3. So your balanced reaction will become S2 plus 3O2 is 2SO3. Okay. Now we shall move to the balancing the chemical reaction, and we have got the idea that how do we balance that. Suppose next example I am considering, we have the nitrogen plus hydrogen, N2 plus S2, and it will give us that ammonia NH3. Ammonia NH3. So whether is it balanced? Two atoms of the nitrogen is present on the left side. Here is only one. So what can we do? We can make it 2 by writing 2 here. Okay. You will ignore to write here 2 since it will change the molecular formula. So best way to write on the ahead of it. Okay. So it will make it 2 nitrogen. So when you will increase this 2 here, you are looking this hydrogen atom will become 6 on the right side, but here is only 2 atom of the hydrogen. So how can you make it 6? By increasing 3. So your balanced equation will be that N2 plus 3H2 is your 2NH3. Next student, suppose we are considering that sodium hydroxide, NaOH. This one is one. So it is called as your sodium. I am writing here. Now you should remember that what it will be called. Sodium hydroxide. And on it we are adding the sulfuric acid. Sulfuric acid S2SO4. I have told you. S2SO4 is sulfuric acid. So here we are getting that Na2SO4 and H2O. So whether is it balanced? 1 atom of the sodium is here, Na is your sodium. Here is 2 atom of the sodium. So what can you do? You can make it 2 by writing 2 here. Now whether is it balanced? SO4 is here. So okay, SO4. 2 atom of the sodium. Okay. Now we will think about the hydrogen. So hydrogen is 2 and 3 here. Okay. No. 2 plus 2 hydrogen here 4. Here is only 2 hydrogen. So here is 4 atom of the hydrogen is present. Here is only 1. Here is on the right side there is only 2 atom of the hydrogen. So how can you make it? By increasing 2 here. So once again check it that 2 sodium, hydrogen 4, hydrogen 2 here, 2, 4, okay. 4 atom of the oxygen, 2 atom of the oxygen will make it 6, and here you are looking 4 and 2 here 6. So the equation will be balanced, and that your balanced equation will be 2NaOH plus S2SO4, which will give you Na2SO4 plus 2H2O. I think it is correct. Okay. Now some more balancing we will do. That you know that respiration equation. Respiration reaction, isn't it? That your respiration reaction is your, we will have that glucose C6H12O6, it is nothing but your glucose, and we take the oxygen from the atmosphere, and carbon dioxide gas will be formed, and there will be H2O as well. So it is our respiration equation, not equation, reaction. This will be called as your respiration reaction. So whether is it balanced? Here is 6 atom of the carbon, here is 1 atom of the carbon. So what will you do? You will increase 6 here, 6. Okay. 12 atom of the hydrogen is present here. Here is only 2. So what will you do? There is 12. Here is 2. So here you will make increase 6 here. So whether is it balanced now? This 6. Okay. 12. 12. Okay. Oxygen. Now check oxygen. Here is 6. Here is 2. 8. Here you are getting 6. Here you are getting 12, isn't? Here 6 atoms of the oxygen, here 12 atoms of the oxygen. So 6 plus 12 will make it what? 18. So what will you do here? Here you are looking only 8 atoms of the oxygen is present only. So that here is 12. Here is 12. And here is 12 plus 6, 18. Here is 6. Here is 8. So can we 8 is there. So if we will make 6 here, we'll make 6 here. 6 2s are 12. 12 plus 6, 18. So you will look that oxygen will also get balance. So your balance equation will be nothing but this 6 C6H12O6 plus 6CO2 will give you 6CO2 plus 6H2O. Now come to the one more example. We are having the iron here, iron Fe, ferrous. Iron, and that reaction of iron with hydrogen we are doing, and we are getting here Fe3O4 plus H2O gas. So now we will balance it. Whether is it balanced? No, you are looking that atoms are not same on the both side. So 3 atoms of that iron is here, so you will increase 3 here. Hydrogen is 2 here, here is 2, okay. Here is oxygen atom is 4. Here oxygen atom is 1 only. So what will you do? You will increase 4 here. Isn't it? Now when you will increase 4 here, you will look that hydrogen atom will become 8 here. Here is only 2 atoms of the hydrogen, but here is the 8 atoms of the hydrogen. So what will you do? You will increase 4 here. Isn't? Hydrogen is a gas, so you will make the arrow upside. That is, I am going to tell to you. So your balance reaction will be nothing but the 3Fe plus 4H2O will give you that Fe3O4 plus 4H2. Hydrogen gas will evolve from here. Is it correct? I think these things are correct. Right up to here. Student, remember one point, that is, remember that if in that chemical reaction we are making up arrow, the meaning is that it is nothing but our gaseous product. Up arrow will show you only gaseous product, and if you are making down arrow, it is saying you that precipitate. It is nothing but our precipitate is forming. Precipitate is forming, and it will go down, miss. So we will represent downside arrow, and that gas will go up. So we will represent gas by up arrow. Now, student, we will move to important point in it, that is types of chemical reaction. Types of chemical reaction. So what are the types of chemical reaction we are going to study, and the different types of chemical reaction is your first one, you can say that combination reaction. Second one is your decomposition reaction. What? Decomposition reaction. Third one is your displacement reaction. What? Displacement reaction. Fourth one is your double displacement reaction. What? Double displacement reaction. And fifth one we shall study that oxidation and reduction reaction. Oxidation and reduction reaction. So these five types of reactions we are going to study. There will be some more reaction like exothermic, endothermic, reducing. Those also I will tell you. Don't worry. That is not in your course, I think, but still I will tell to you. Now come to the combination reaction. This is the first reaction. Okay, we shall study. And what is combination reactions? That reactions in which two or more substance combine to form a single substance. So you are looking that two or more substances will combine to form single substance. That is why it will be called as your combination reaction. And the form of it will be, suppose this A plus B, two substance we are choosing, and it is forming a single substance AB here. So it will be the example of your, it is the general representation of that combination reaction. Some examples can be your, that suppose we are considering iron plus sulfur, it will make FeS here. Of course, this H2 plus O2 will give you that 2H2O, and here will be 2, and nitrogen plus hydrogen is ammonia, this NH3, N2 is there, so 2NH3 here, 3H2. Okay, so these are the examples of your combination reaction. Have the screenshot. Next, I'm telling to you that we will have some more example based on it. I'm rubbing here. That suppose you are considering calcium oxide. Calcium oxide. CaO. CaO is nothing but your calcium oxide. Calcium oxide is also called as your lime or quicklime. Lime or quicklime. And you are reacting it with water. So quicklime we are reacting with water. So you will look that your two substances here will form one single substance, and that will be called as your calcium oxide, hydroxide. Calcium hydroxide. CaOH whole twice will be called as your calcium hydroxide. So it is one more example of your combination reaction, and you can have that ammonia NH3, and this NH3 when we are reacting with HCl, HCl is called as your hydrochloric acid. Hydrochloric acid. It is nothing but your ammonia. So ammonia when are we reacting with HCl? HCl is your hydrochloric acid. Sulfuric acid is your H2SO4. HCl, you know that in your stomach that HCl is present. Hydrochloric acid is present. So that HCl, hydrochloric acid, and this will give us ammonium chloride, NH4Cl. Ammonium chloride, NH4Cl. So two substances is combining, forming one single substance is the combination reaction. We will move some other examples as well. For that, have the screenshot. I am rubbing here. Suppose you know that means this 2CO plus O2 is nothing but your 2CO2. This is carbon monoxide. Carbon monoxide. When that means carbon is not burning completely, it will form that carbon monoxide, and in the presence of oxygen it will form carbon dioxide. Oxide. So other example is your important example. When are we considering that hydrogen H2 plus chlorine Cl2? It is nothing but your chlorine. It will form hydrochloric acid, H2HCl. Hydrochloric acid is present in our stomach. So this 2HCl, hydrochloric acid will be formed. Hydrogen chloride, you can say for the time, hydrogen chloride. It is your hydrogen chloride. And remember that hydrogen chloride is used to form, this hydrogen chloride is used to form hydrochloric acid. Hydrochloric acid by dissolving in water. By dissolving in water. So that H2 and Cl2, that hydrogen and chloride will give you hydrogen chloride, 2HCl, and this hydrogen chloride is used to form the hydrochloric acid, and that hydrochloric acid you will form by dissolving in water. Okay, so you will remember it. Look students, that your hydrogen gas and chlorine gas is very pure when you will make by the brine method. These are very pure, and when these two gases will react, they will form hydrogen chloride, 2HCl. Okay, hydrogen chloride they will form, and it will be in the gas form. So for that gas we will put the up arrow, and this gas, when we dissolve in water, it will form hydrochloric acid. It will form hydrochloric acid. Will form hydrochloric acid. Either you can use as a gas, or you can dissolve this gas into the water to form the hydrochloric acid, and that is also nothing but your HCl only. And you will keep it into the special vessel of graphite. Special vessel of graphite. Graphite is present in your pencil lead. Black color of pencil lead is your graphite. So that vessel made up of graphite, in that you will place this hydrochloric acid, and it is concentrated, and naturally it is found in your stomach. You know that non-vegetarian have the chickens, all these things. So this hydrochloric acid helps to digest those things. Next student, we shall move to the decomposition reaction. What? Decomposition reaction. First one was that combination. Next is your decomposition reaction. So what is in that decomposition reaction? That in this compound splits into two or more substances. So here the compound will split into the two or more substances. Suppose we have the A here, and on the decomposition reaction it is splitting into B plus C. So it will be your general representation of it. And you have looked that by the reaction of calcium oxide with water we have formed the calcium hydroxide. Okay, leave that reaction. Consider this calcium carbonate. CaCO3 is called as your calcium carbonate, and it is called as your limestone. Calcium hydroxide was different. it is different. Calcium carbonate, and this calcium carbonate, when you will heat, you will have the calcium oxide. You will have the calcium oxide plus CO2 gas will evolve. It is your calcium oxide, and calcium oxide on reaction with water will give us calcium hydroxide, CaOH whole twice, that I have told you earlier. So that limestone, that is your limestone, is that chuna, when you will that heat up, it will give us calcium oxide, plus in that you will look that bubbles will form when you will that put water on that tuna in that general way we know. So that bubbles is of that CO2. These bubbles of CO2. Okay, carbon dioxide, you know. 2 oxygens or dioxide. So carbon dioxide. So next was your decomposition reaction. We will note down some points in that decomposition reaction. That suppose this A compound is splitting into the B plus C, and student, if you are finding a kind of symbol, it is called as our delta. So the meaning is of delta is the heat or temperature. If either they are writing temperature or something with 2000 degrees Celsius. So this kind of that reaction will be, this kind of the decomposition reaction will be called as our thermal decomposition. This kind will be called as our thermal decomposition. Thermal decomposition. And in this we can have the examples like that. When are you considering that potassium chlorate, this 2KClO3, it is nothing but your potassium chlorate. When you will take potassium chlorate and heat it, you will heat it in the presence of MnO2 catalyst. It is what? It is called as our catalyst. What is catalyst? Catalyst is used to increase the rate of reaction. Increase the rate of reaction means some reaction can be slow, so to increase the rate of reaction we will use the catalyst, and here in this case we will use the MnO2, magnesium dioxide, we will use as our catalyst. And you will look, in this case potassium chloride will be formed. It is nothing but our potassium chloride plus 3O2 will be formed, plus 3O2. So it is our oxygen is our gas, so it is used to produce oxygen. It is used to produce oxygen. You will remember that how can you that make oxygen? By this way. Next we can consider that carbon monoxide, one oxygen, so carbon monoxide, it is our gas. Carbon monoxide plus carbon monoxide plus, no, leave it, I'm sorry, I'm sorry. Say and suppose we are considering, 2FeSO4, ferrous sulfate. Ferrous, either you are saying ferrous or iron, both is same. Ferrous sulfate, and it is in your green color. It is in your green color, and that you are heating it, so you will get ferric oxide, Fe2O3, ferric oxide plus sulfur dioxide plus sulfur trioxide. 2 oxygen dioxide, 3 oxygen trioxide. So it is nothing but your ferric oxide. Ferric oxide, and it will be your in brown color. So if that color is changing, so there will be the chemical reaction I have told you. So that green color of that ferrous sulfate is changing into the brown color of ferric oxide, and here sulfur dioxide and sulfur trioxide is forming. So it was that next examples of that decomposition reaction. Have these screenshots. Next come to the one activity, and in this activity, with the help of this burner, we are heating lead nitrate, lead 2PbNO 3 whole twice, NO3 whole twice, 2PbNO3 whole twice. This is nothing but your lead nitrate, and it is our colorless. When are you heating it with the help of burner, you will look, it will form, I am writing here, you will not write in the break form, you will write in a single line the chemical reaction, but here for the space I am writing here, will form lead oxide, 2PbO, lead monoxide plus 4NO2 nitrogen dioxide plus oxygen. Okay, so that lead nitrate you are heating, and it will form lead monoxide, and it will be your yellow in color. It will be yellow in color. Okay, or you can write by yellow. It will be yellow in color, and here the nitrogen dioxide will be brown in color. It will be brown in color. So it is the activity of heating of lead nitrate, 2PbNO3 whole twice, and in this, that observation is that when are you heating lead nitrate by the help of burner, you will get brown fumes of nitrogen dioxide. The brown fumes of nitrogen dioxide will emit from here or evolve from here. So that brown fumes of nitrogen dioxide will emit. Okay, So it was an activity of that decomposition reaction, that lead nitrate we are heating, and that one compound is splitting into the two and more substances. So next point of note is here, it is note second in the same decomposition reaction, that suppose a compound is here and it is splitting into the two substances B and C, and here they are writing something 5 ampere. Ampere means that current you will measure in ampere, and here 10 volt they are writing. So such kind of the reaction will be called as our electrolysis. And electrolysis is very famous in the case of that water. Suppose we are considering 2H2O and performing that electrolysis process, so it will give us hydrogen 2H2 plus O2. Hydrogen and oxygen we will get. Next we shall move to the activity of the electrolysis of water. So we are moving to the activity of electrolysis of water, and where we have the mug, and in that mug water is here, and we are using two electrodes, that one is anode, another one, this is electrode rod. In the test tube we are using the electrode, and that is of that graphite. Graphite rod is here in that test tube, and that one is anode, one is called as your cathode. Look, anode will be positive, cathode will be negative. How can you remember that A comes first? So A will be positive. C comes later, so C will be negative. In this way you can learn, I think. So that we are connecting with a 6 volt battery, and here is your switch. So water is here and we are performing the electrolysis process. So that 2H2O we are considering, and on this switch, when will be on this switch, our observation will be formation of bubbles at the both electrodes, so that bubbles will form in both the electrodes. Here bubbles will form, and it is the bubble of oxygen and it is the bubble of hydrogen. Oxygen will be at the anode. You will remember anode is positive. So oxygen is negatively, valency is your negative. So oxygen will form at the anode. Hydrogen have the valency +1. Alkali metal, please go to the periodic table and first study that periodic table, then only you can understand this. So positive will be at the negative. So that negative will come to the positive and positive will come to the negative to that balance that, or you can say neutralize that current. So that 2H2O, when are we that performing electrolysis process? Electrolysis process means what? electrolysis we are doing, means that providing, giving electricity, you are looking that here you will form, here it will form 2H2 plus O2. Okay, so it was the activity of that electrolysis process, that electrolysis of water. Here we are getting a problem that why is the amount of gas is collected in one of the test tube in the electrolysis of water experiment. So why in one electrode you are getting the double amount of gas than the other test tube? It is because H2O contains two part of hydrogen as compared to one part of oxygen. So it will be our answer, that because H2O will contain two part of the hydrogen as compared to the one part of oxygen. Now point number 3 to note in that decomposition reaction, that suppose a compound A is here and it is splitting into B plus C, and here you are finding light, that it can be sunlight or bulb light. Sunlight or bulb light, they can write that H nu, it is the symbol of nu, H nu as well, you will study in that 11th class. H nu also they can write, it is representing the light energy only. So such kind of the reaction will be called as our light decomposition. Light decomposition. Light decomposition. And next we will have the examples. Examples you can have the, suppose this 2 silver chloride, 2AgCl, it is nothing but our silver. Silver, you know, silver, Cl is there, so silver chloride. And when that light will fall on this silver chloride, it will form silver, 2Ag. Okay, silver and chlorine gas you will form here, will be formed here, chlorine. Okay, you will note down that your silver will be that grayish white, it will be your grayish white, and chlorine will be your yellowish green, yellowish green. And it is used in that photography. It is used in photography. What will you use? That silver chloride or bromide. Silver bromide is generally used. So used in black and white photography. You can have the next one as well. I am rubbing here. You can have the screenshots. That in the same way AgCl was present here. You can have that AgBr as well. AgBr, it is nothing but your silver bromide. And that when are you giving light? So that silver 2Ag will be formed, plus bromine gas will come here, Br2, and it is silver. Bromide is your pale yellow in color. Silver is your grayish white only. Silver, it is silver here. It will be grayish white at both the places, grayish white. And here you will form that here it will form bromine, and it will be red brown in color. Generally we use this silver bromide in that photography, so it is used in photography, black and white photography. Now we are not using, but in old times it is used to be used as your black and white photography. So we have seen that things in that decomposition reaction. Now we shall study that use of decomposition reaction. What are the uses of decomposition reaction? So that it is used to extract several metals. Okay, several metals. What are metals? Where it is present? Go to the periodic table. Several metals from their naturally occurring compounds like oxides or chlorides. So suppose we have the metals oxides and metals chloride compound, so we can extract metal from that. And how can we that extract? Suppose that this 2NaCl, sodium chloride, it is sodium chloride. And when are you providing that electricity on it? We are doing that uses electricity on it. It will give us 2Na plus Cl2. This chlorine gas will be formed. So it is nothing but our sodium metal. In the same way, we can have that 2Al2O3. It is nothing but our aluminium oxide. You will remember all these things. Study 2, 3, 4 times, it will get remember, I think. Aluminium oxide. And this aluminium oxide, when are you providing electricity, it will give you 4Al plus 3O2. Electricity will be called as your that electrolysis process. 3O2, this O2 is your gas, so it will be upside. So it is nothing, we will get aluminium metal from here. So you are looking that we can extract the metals from their compounds of oxides and chlorides with the help of that decomposition reaction. Now in digestion as well, also decomposition reaction takes place. Okay, so in digestion also there will be the decomposition reaction. Remember student, I have told you that digestion takes place in the stomach, but it will start from your mouth. That your digestion starts from your mouth itself. You will study in your that biology. Okay, decomposition reaction finished. Now come to that displacement reaction, student. That in your displacement reaction, one element takes the place of another element. One element takes the place of another element. Here is the general form of it. General form is that suppose AB is here plus C when you are doing. If C is going at this place, means suppose AC is forming, C is going at the place of B and displacing that B, or C is going to the place of A and displacing to the A. So such kind of the reaction will be called as our displacement reaction, or it is also called as your substitution reaction. We are substituting some that element at the other place, means at the place of other element. So it will be called as our displacement reaction. One element takes the place of another element. Its general form will be in this way. But it depends on the reactivity. What? It will depend on the reactivity of the element. Reactivity of the element means, suppose if this C is less reactive than the element present here, so it will be not able to displace it. Okay, so that will depend upon the reactivity of that element, and for that we have the trick here. And don't give me the credit of it. The credit will go to my teacher. He has told to me that how to learn the reactivity of the element, and that will we read that लीना के बापू ने काका से मांगी. So who is asking that? लीना के बापू ने. Lina's bapu is asking. To whom it is asking? काका से मांगी. What he is asking? अलमारी जमीन करोड़ रुपए. अलमारी जमीन करोड़ रुपए. लोहे की सीढ़ी को. That stairs is of that लोहा. लोहे की सीढ़ी को नीचे से पुतवाओ. So that नीचे से we will that paint that लोहे की सीढ़ी. तांबे चांदी की प्लेट. तांबे चांदी की प्लेट और सोना. So in this way you will that remember, and that meanings are nothing but your that Li, Lina means that Li, K means K potassium, Bapu means barium, Ba, Na means sodium, Na, Kaka, calcium, Se, S or strontium, Mangi, magnesium, Almari, aluminium, and Mn, magnesium. Okay, not manganese. Mn will be there. I will tell you. No? Right now I am not able to tell you that what is Mn. That almari Mn. Jameen means Zn. Crore rupaye Cr. Loha means what? Iron. Fe. Cd. Niche means Ni, nickel. Putwao will be Pb, lead, sisa. Okay, glass, lead. Tamba you know, Cu. Chandi is your Ag. Ag is your Chandi, silver. Plate means your platinum. And that Sona is your, you know that it will be Au. And student, please remember that here will be hydrogen. After this Pb, you will have that hydrogen here. Okay, hydrogen. So this is our that reactivity series of that elements, and from left to right you will write it in one line, and left to right that your reactivity increases. Your reactivity will increase. First note down these things, then after we will move to the other things present in the displacement reaction. Displacement reaction, one that element will take place the other element, and it will depend upon the electrochemical series, and that is how, what is the way of learning, I have told you. Read it, and when you will that go 4-5 times to it, now it will become learned to you. So we have came across the reactivity series, and what is the way of learning it, I have told to you. It is nothing but our magnesium. Mn is your magnesium, Mg is your manganese. So we will note down some point in it. Note, gold Au is least reactive. Is least reactive. And that hydrogen comes, where the hydrogen is coming? Hydrogen comes after Pb, lead, after Pb, that is your that glass, and it is, hydrogen will come after that Pb, and it is more reactive, than your hydrogen will be more reactive than your copper, silver, platinum, gold, etc. Not etc. It will be more reactive than the copper, silver, platinum and gold. So come to that one question of it, that which will displace displacement reaction is there, so which will displace copper, Cu. That your options are that silver, B is your that gold, C is your platinum, D is your, you can say, iron. So you will look that copper, where the copper is coming, Cu, copper is coming here. So which will displace this copper? Whether Ag, since the Ag is coming after the Cu, so Ag will not displace it. Au will not displace copper. Platinum, that will not displace the copper, and iron is coming here, so that iron is coming first, and this Ag, platinum and Au is coming after the that copper, so that only iron will be there which will displace the copper. So for that, Miss, left to right reactivity, I am sorry that no student, that left to right, I have told you that left to right, now please ignore that. Left to right reactivity will decrease. Left to right reactivity decreases. Sometime before I have told you that it will increase, please cut that. Reactivity increases left to right. Please note it. I am sorry for that. Left to right reactivity will increase. The element which will come first will be more reactive than the element which will come after that. Now, before some time I have told you that left to right reactivity will that increase. It is not there. I'm sorry. Here reactivity, once again I have made the mistake. Reactivity will decrease. Okay, decrease. Please keep it in your mind. I'm sorry for that. Come to an example. Example we are considering, and in this example we have the copper sulfate copper sulfate solution. Okay, copper sulfate solution, and it is blue in color. And here we are having the zinc strip. So what do we have? We have the copper sulfate here. Copper sulfate solution is here, which is your blue in color. It is nothing but your copper sulfate. You will remember that what will be called. I am writing for your benefit. Copper sulfate, it is blue in color, and we are reacting it with Zn. So whether will it react or not, you will go to the reactivity series and you will look that Zn will come first and Cu will come after the Zn. So of course it is more reactive, so it will react with it. And what will you look, that we will have the zinc sulfate here, ZnSO4, zinc sulfate, and here you will form here you will get the copper, zinc sulfate, copper. So when that zinc will react with copper sulfate, we will get zinc sulfate and copper, and this zinc sulfate will be a colorless solution. Colorless, it will be the colorless, and copper will be your red brown. You know the color of that copper, it will be red brown. So you are looking that when we are considering a zinc strip and that we are dipping in that copper sulfate solution, here a colorless solution, that colorless solution of zinc sulfate will be formed, and that copper from that copper sulfate solution will get deposited on the zinc strip and it will become red brown in color. So our reaction will be something like it. Okay, so that your observation will be that blue color of copper, sulfate. You are looking that copper sulfate have the blue color. Copper sulfate fades. It will get fades due to the formation of zinc sulfate. Due to the formation of zinc sulfate. Zinc sulfate is your, which is colorless. And next observation we will get that a red brown deposit of copper, red brown deposit of copper on zinc strip, on zinc strip. So what are we looking? That blue color of copper sulfate will fade into the zinc sulfate, colorless zinc sulfate, and the copper will get deposit on that zinc strip, which will become red brown in color. So it is the first example we are considering. Here you are looking that zinc displaces copper from the copper sulfate solution, and this displaced copper forms a red brown deposit on zinc strip. So that copper zinc will displace the copper, and a deposit of red brown will come on this copper. Okay, I think this example is understood to you. Okay, try to understand. And next, suppose student, we are considering the, now I am rubbing it here, that next example we can consider, that suppose once again, now second one example we are considering, that we are having the copper sulfate solution. Copper sulfate solution will be your blue only, it will be blue only, and if we are reacting it with that magnesium, whether will it react? Of course it will react. That magnesium will come first and copper will come after it, so it will get react and it will form that magnesium sulfate solution. Magnesium sulfate solution, it will be that magnesium sulfate solution, which will be colorless, and here that copper will be formed, which will be the red brown in color. So of course, in place of zinc strip, if we are considering the magnesium strip, so that will become that fade, and it will become the colorless solution of magnesium sulfate. That blue color of copper sulfate will change into the magnesium sulfate colorless solution, and that red brown deposit of that copper will come on that magnesium strip. I am giving you this example based on this. I think you can understand it. Now student, tell to me that suppose we have that zinc sulfate solution and we are reacting it with this copper, whether will it react? When you will go to that reactivity series, you will look that zinc will come after the copper. So here no reaction will take place. There will be no reaction. So you will remember that reactivity series, that which will come first. If only the more reactive element can displace the other element. Okay, so that copper is less reactive than Zn, so there will be no reaction. You will remember this all. Now we will look at some more examples of that displacement reaction, and the first is your that copper chloride CuCl2, which is green solution, and that we are reacting with lead, which is blue is gray. So whether it will react or not, for that you will go to the reactivity series and you will look that Pb will come after the copper, so that Pb will come before the copper, so that Pb will be more reactive than copper will come after the Pb, so the reaction will take place, and that reaction will be that PbCl2 lead chloride here, which will be colorless solution, and plus copper here we will get, that will have the red brown color. Next we are having the iron. Iron we will take here as iron filling. Iron we will consider as our iron fillings, and that when are you reacting with hydrochloric acid. Hydrochloric acid means what? HCl, isn't it? And sulfuric acid is your H2SO4, HCl is your hydrochloric acid. I have told you about these things. So this iron and HCl, so you will look, this reaction will give us that iron chloride here, and hydrogen gas will be formed from this reaction. So here that hydrogen gas is formed. So you will look that by this way also we can have the hydrogen gas. Next reaction we are considering that Fe2O3. Fe2O3 is ferric oxide. Ferric oxide. Look that you will not say ferrous. Ferrous will have that 3 here. It is 2, so ferric oxide. Ferric oxide or iron oxide both is same. So that when are you reacting with aluminium, you will look that aluminium will come first and iron will come after the aluminium. So aluminium will be more reactive. So we will have that aluminium oxide here, Al2O3, and that iron will be formed in that molten state. So that Fe2O3 ferric oxide when it will react with aluminium, it will give us aluminium oxide and iron will be formed, and very much heat is produced in this reaction. You will look that in this reaction you will have very much heat will be produced in this reaction. A kind of the blast will take place for having the iron. To get the iron, this reaction you will consider, and that will have the very high heat it is going to produce. So these are some more examples. And look students, suppose I am considering that H2O, when are you reacting with silver, it is giving you Ag2O, silver iodide, and this hydrogen gas is producing. So can we write this equation? Whether is it correct or not? No. Why is it not correct? You are looking that Ag is your less reactive than hydrogen. I have told you. Go to the reactivity series and you will look that Ag will come after the hydrogen. So since Ag is coming after the hydrogen, it will be less reactive. It will be not able to displace hydrogen from here. So no reaction will take place here. So here will be no reaction. Okay. Displacement reaction up to here. We have seen the displacement reaction. Now we shall move to the double displacement reaction. It is double displacement reaction, and what is in that double displacement reaction? That two compound react by an exchange of ions. That two compounds will react by the exchange of ions to form two new substances. Or compound, you can say, they will form. So that two compound will react with each other by the exchange of ion, and they will form two new compounds. That general form will be that suppose we are having AB here and that we are reacting with CD, so that we are getting either AC plus BD, AC or BD, or we can get AD plus BC. Okay, so it will be our general form of it. Suppose we are considering that AgNO3, silver nitrate. It is our silver nitrate, and that we are reacting with NaCl, sodium chloride. Sodium chloride, you know it. It is sodium chloride. When you will react, you will look that it will form AgCl, silver chloride, and plus NaNO3, means sodium nitrate here. So you are looking that sodium is going at the place of silver and silver is coming at the place of sodium. So that sodium is going at the place of silver and forming sodium nitrate here, NaNO3, and silver is coming at the place of sodium and forming silver chloride here. So a kind of that double displacement is taking place, and such kind of that reaction will be called as our displacement reaction. Have the screenshot. Now come to that example of that double displacement reaction, and in that double displacement reaction we are having the two solution here, and that is of that barium chloride, BaCl2, barium chloride, and having the sodium sulfate, Na2SO4 here. It is nothing but our sodium sulfate, and that two solutions, when are we mixing, here mixing is taking place. So you will look that it will give us that barium sulfate, BaSO4, barium sulfate here, and plus 2 NaCl, sodium chloride. So it is the next example of your double displacement reaction. You are looking that SO4 is Na, sodium is going at the place of barium, and barium is coming at the place of sodium, so that double displacement is taking place, and by mixing here we will get the precipitate of barium sulfate. Don't forget to write the figure of that name of the figure, and it is the double displacement reaction between sodium sulfate and barium chloride. So it is the example of your that double displacement reaction. Now we will look some more examples of that double displacement reaction, and that first example is saying that when are you reacting this copper sulfate, CuSO4, with hydrogen sulfide, you will have that copper sulfate here, Cus plus sulfuric acid, H2SO4. So you are looking that hydrogen is going at the place of copper and copper is coming at the place of hydrogen. So it will be an example of double displacement reaction, and you guys will look here a black PPT will be formed. In the same way, that second example, we are considering aluminium chloride and ammonium hydroxide, AlCl3 and 3NH4OH, and when are we reacting it, we are getting that aluminium hydroxide, AlOH whole thrice, and ammonium chloride, NH4Cl here, and you are looking that NH4 is going at the place of aluminium, aluminium is coming at the place of ammonium. It is nothing but, I am sorry, here aluminium will be not here, aluminium is not here, it is ammonium. Okay, ammonium. ammonium. Okay, ammonium hydroxide. So you will get that when that aluminium chloride is reacting with aluminium hydroxide, that ammonia is going at the place of that aluminium is coming at the place of ammonium, and you are having the aluminium hydroxide here, and ammonium chloride is forming at here. So you will look that since that displacement, double displacement is taking place, so it is also an example of that your double displacement reaction, and here you guys will look that white PPT will be formed. PPT means that precipitate. So here you will get white precipitate. In the same way, third one is saying that lead nitrate PbNO3 whole twice. When are you reacting with that Ki? Ki is nothing but your potassium iodide. That potassium will go at the place of lead. Lead will come at the place of potassium, and here that lead iodide will be formed PbI2, and that potassium nitrate means that KNO3 will be formed, and here you will get yellow PPT. Yellow PPT. So it is the example of your that double displacement reaction. For the time first time you can that read out only the activity is one example, and by repeating that twice and thrice, when are you coming at the fourth and fifth time, then I think you should go to these example for your that simplicity. I am suggesting it's your wish. How are you doing? I am not suggesting anything to you. Now we shall study that oxidation and reduction reaction. So for that we will write oxidation here, and here we will write reduction. Oxidation and reduction. So oxidation is nothing but your addition of oxygen and removal of hydrogen. So where the oxidation will take place, where we will add the oxygen or we will remove the hydrogen, that will give us oxidation. So that oxidation is the either addition of oxygen or removal of hydrogen. In the same way, reduction reaction is nothing but the removal of oxygen or addition of hydrogen. Okay, getting? So it is your definition of that oxidation and reduction, and here you guys will look that we will have that oxidizing agent and oxidizing agent and reducing agent. So what is oxidizing agent? Oxidizing agent is nothing but our the substance which gives oxygen is called as our oxidizing agent, or second you can say that substance which remove hydrogen. So that substance which is removing hydrogen and giving oxygen will be called as our oxidizing agent, and whereas in the case of that reducing agent, that substance which gives which gives hydrogen, or you can say substance which remove oxygen. So oxidizing agent is the substance which is giving oxygen and removing hydrogen. Reducing agent is that which is giving hydrogen and removing oxygen. Don't get confused between that oxygen and hydrogen, which is giving what and which is removing what. So for that, be precise in it. Okay, carefully read it. Have the screenshot. Move to the examples of that oxidation and reduction reaction. I am writing a reaction here, that is copper oxide plus hydrogen. When are you heating, delta sign, for that heat you are getting copper here plus H2O. So here you are looking that from copper oxide that oxygen is removed and we are getting copper here. So here is the removal of oxygen. Removal of oxygen is taking place. So removal of oxygen is what? Nothing but our reduction, isn't? Addition of oxygen is oxidation, removal of oxygen is your reduction. So from copper oxide, copper you are getting, so removal of oxygen, reduction is taking place here. Here from hydrogen you are getting H2O. So here what are you looking? That addition of oxygen, and addition of oxygen is called as your what? Oxidation. So here what is taking place? Oxidation is taking place. In the same way we can consider one more example, that magnesium. When it is not magnesium oxide MnO2 you are having, and that we are reacting with hydrochloric acid, and when you will react it you will get MnCl, magnesium chloride, plus Cl2 plus H2O here. So here you are looking that from magnesium oxide to magnesium chloride your oxygen has got removed. Magnesium has got removed. So here what is taking place? Reduction. This reduction here it is taking place, and here you are looking that from, if you are choosing that hydrogen here, so here that chlorine is that removing and oxygen is getting add here, so that here is that addition of oxygen, so it will be our oxidation. Here it is taking place, and you will look that MnO2 here the reduction is taking place. Since that it is removing oxygen, so it will act as your oxidizing agent. Where that reduction will be there, that will be oxidizing agent. MnO2 is your oxidizing agent. Here that HCl will act as our reducing. Oxidation is taking place, so act as your reducing agent. Okay, please be careful in these things. I think when you will read it, you can understand. Now we will look some more things in that oxidation and reduction, consider one example. I have told you that N2 plus 3H2 will make the ammonia 2NH3. So in this we want to check that whether the oxidation is taking place or reduction is taking place. So by N2 we are considering this. So there is an addition of that hydrogen. Addition of hydrogen will be nothing but your reduction is taking place. Okay. Now choose this hydrogen and compare it with this. With hydrogen, what is happening? Oxygen is not coming, removal of hydrogen, how can you say? So with hydrogen, how can you check that what kind of that reaction will be here, whether it will be that oxidation or reduction? So for that I want to tell to you student that you will say this is your oxidation reaction, and what are the things to which you should note that here in that reduction, if oxygen is your what? Oxygen is that your electronegative element, means valency of that oxygen is negative. In periodic table I have told to you. So oxygen is negative, nitrogen is also your electronegative element. So here you will look that reduction, how can you recognize that addition of electro positive element, positive element. So here that with nitrogen electropositive, hydrogen is coming, it is your electropositive. So this will be your reduction reaction. And how can you recognize if that addition of electropositive element is taking place? So there will be reduction. With hydrogen you are looking a electronegative element. Electronegative is your nitrogen. So that oxidation also you can recognize that addition of electronegative element, and that nitrogen is your electronegative element. And here you are looking that here oxidation and reduction is taking place simultaneously. So such kind of the reaction will be called as our redox reaction. What? Redox reaction. In redox reaction, that oxidation and reduction takes place simultaneously. Simultaneously means simultaneously means together. So together that oxidation and reduction is taking place. So that kind of that reaction will be called as our redox reaction. And you will remember that if that addition of electropositive element is taking place, so that will be there will be reduction. If addition of electronegative element is taking place, so that will be the oxidation. This thing also you will keep in your mind. Okay. Consider this one example as well. Suppose we have the copper here 2Cu, and that we are reacting with oxygen O2. So we are getting that 2CuO here. So with Cu, that addition of that oxygen is taking place. So here will be that oxidation. Here will be oxidation. Now when you will compare this oxygen with it, So you are looking that how can you recognize that with oxygen Cu is coming. So what will be your oxidation or reduction? You may get confused. So for the time it will be that reduction reaction. It will be the reduction reaction, and for it, what will you remember? That for oxidation there will be that addition of non-metallic element, or you can say removal of metallic element. So if here addition of metallic element is taking place, so that is oxidation, or you can say removal of metallic element taking place, addition of non-metallic element taking place, so oxidation or removal of metallic element. In the same way you can say reduction, for reduction here that addition of metallic element, or you can say that reduction of, not reduction, removal of non-metallic element. So this thing also you will keep in your mind, that oxidation can be also that addition of non-metallic element and removal of metallic element. Reduction can be that addition of metallic element and removal of non-metallic element. So here when are you looking to the oxygen in this metallic element, copper is being added. So addition in here, reduction, addition of metallic element is taking place. So it will be the reduction. Reduction will take place here. Here you are looking that metal, that oxygen is your non-metallic is coming. So addition of non-metallic element will give you oxidation. These things also you will keep in your mind. Now we shall move to the effects of oxidation. Effects of oxidation we are saying, not reduction, or the oxidation reaction. So what are the effects of oxidation reaction? Here will be I. Oxidation reaction, that corrosion of metals and rancidity of food. Rancidity of foods can be that your effects. So first we shall move to the corrosion, and you all will be aware about it, that corrosion is the process in which metal are eaten up gradually by the action of air, moisture or chemicals. So that by the action of air, moisture or chemical, if that metal are that decaying or it is being eaten up, so that will be called as our corrosion. And that example of have this screenshot. Example of corrosion is your rusting. Example can be the rusting. Example of corrosion is your rusting. What is rusting? Oxidation caused by the oxygen of air. So that oxygen of air will be also called as your aerial, A-E-R-I-A-L, aerial oxidation. So if that by the air oxidation is taking place, that will be called as our aerial oxidation. So oxidation caused by the oxygen of air is called as your aerial oxidation, and in this, that oxygen in the presence of moisture cause rusting, and that in rusting, that we have that iron and 3O2.2X moisture is present here, and that will give us that rust, and that is 2Fe2O3.XH2O, and it is your hydrated iron oxide, and it is also called as your rust. So it is the rusting. You will remember that iron will react with oxygen of air in the presence of moisture, and that oxygen, or that by the action of that oxygen of air, if that oxidation is taking place, that will be called as our aerial oxidation. So please note down these things. Next effect of that oxidation we are studying is the rancidity. So what is rancidity? When fats and oils are oxidized, they become, so that when oil and fats will get oxidized, they become rancid. They will become rancid, and their smell and taste changes. So that when fats and oil are oxidized, they become rancid, and their smell and taste will get changed. So what are the prevention of that rancidity? Preventions we can have that by adding antioxidants. When are we adding in that? That can be our prevention. Next can be packaging in nitrogen gas. You will look that in your chips packet there will be nitrogen gas. You will remember that in chips packet there will be nitrogen gas. So by packaging in nitrogen gas can be also your prevention. Next can be your that keeping food in refrigerator. Keeping food in refrigerator is also the prevention of that rancidity. Next I am writing here that storing in airtight containers and I'm writing here storing food away from light, so that it should not be near to light, it should be away from the light. This can be your prevention, and prevention of corrosion you can do. I think that is your homework. You can have that prevention. Now we are reaching at the end, and that exothermic reaction and endothermic reaction is also in your course, so we should know that. What is exothermic reaction? In exothermic reaction, heat is released. Heat will released. So when heat will released, surrounding temperature increases. Here heat is absorbed. Here you will absorb the heat. Heat is absorbed, and when the heat will absorb, surrounding temperature will decrease. So these are the exothermic and endothermic. Exo means exit, heat will release. Endo means ending, means heat will absorb. So examples can be your all burning of combustion reaction. Burning reactions, combustion reactions will be the exothermic reaction. Respiration reaction can be that your exothermic reaction. Burning of magnesium wire, burning of magnesium wire is also the example of exothermic reaction. In the same way, we can have that examples in this as well. All decomposition reaction will be that your endothermic reaction. Okay, melting, boiling, and that photosynthesis. Okay, photosynthesis is what? Reverse of that respiration. So that respiration is your exothermic, whereas photosynthesis is your endothermic. Next can be your electrolysis of water. Electrolysis of water as well. So this thing also you should know, exothermic and endothermic. Exothermic, heat will release. Endothermic, heat will absorb. The examples are written here. I am rubbing here, students, that what will be that way of writing it. That exothermic reaction you will look that suppose we are having A, B and we are getting C plus D here. So in that exothermic reaction, heat will release. So that general representation can be in this way. So heat is releasing, so that general representation is in this way, or they can write in this way as well. A plus B minus of heat here. Minus of heat C plus D. So it will be that exothermic reaction. Here endothermic, how can they write? A plus B is your C plus D. Minus of heat will be in that product, or here it can be plus heat in the case of that reactant, in the case of that endothermic reaction. So these things you will keep in your mind. It's end here. Reversible and non-reversible is not in your course. So for the time you can leave that. Thank you all of you.